Okay, so let's continue from where we left off. Yeah, so it's 1/3 here. Good. So, like we were saying, once you've obtained the form B I inverse, okay, now the factor outside the bracket, which is 3 times 1/3 is also 1, okay, then it means that our solution, okay, x is equals to what? 3, and then y is equals to what? Y is equals to 2. Okay, whilst your inverse of the matrix, okay, is what? 3. The inverse of the matrix is 3, -4. We have -4, and we have 3. Yeah. Okay, and we have the determinant of the system is equals to the determinant of the matrix A, okay, is equal to 1, okay, which can be verified, okay, using other techniques. Yeah, very well. So in summary, what we are saying is this GJ approach, okay, gives us, let's say, a 3-in-1 package, okay, gives us 3-in-1 package, okay, at a go, right? And it's quite exciting to use it, okay? But you see, sometimes we may not be necessarily interested in the inverse and the determinant of the system, okay? I may just ask you to solve it. And once you've been asked just to solve the system, okay, then the focus is on the solution, okay? So instead of transforming the whole thing into this form, okay, we may rather be interested in just transforming uh, AB, which is 2, 3 to 4, 3, okay, 4, 3, 13, 8, 13, 18, okay, and then we just transform it into what? Into the form 1, 0, 0, 1, okay, and then the final solution, I think we had 3, 2, okay, yeah, so then you forget about the last component, which is the identity component here, okay? So the question then is, when do I use what, okay? In examination, if I ask you, or in any of your assessment, if I ask you to solve using the Gauss-Jordan approach, okay? So you have the Gauss-Jordan approach, okay? So I ask you to use Gauss-Jordan, okay, to solve the system. Then I come with a follow-up question, okay? Hence, okay, anytime you see the word hence, then I'm telling you that hence find what? Find the determinant of the system. Find that of A, okay, or the inverse of A, okay? Then what I'm telling you to do is to use the full expansion for GJ, okay, okay, to find the solution, find the determinant, find the inverse. The moment you see hence, okay? But if I write hence or otherwise, meaning that you can use the general method of finding what? The determinant, okay? Okay, so for a 2 by 2 matrix, you know how to find the depth of A. Okay, so determinant of a matrix A is just what? If we have A, you know this, so A, B, C, D, Okay, that would be AD, okay, minus what? CD, okay, then you can use that approach, okay. But the moment I write hence, then I'm limiting you to the full expansion of the GJ. You have to still use stick, limit yourself to the Gauss-Jordan method, okay, not to any other method. So when you see that hence, and I follow up with hence find the determinant, hence find the inverse of the matrix, then I expect you to use only the Gauss-Jordan technique. Please take note of that, okay? Once you see hence, don't try to, I mean, play around and say you didn't know. I'm stating it clearly, explicitly in class, okay, so that you don't make that mistake. But if you forget and you make the mistake, I'll mark it wrong for you, okay? Because here we are more interested in the approach. It's not about the solution. Yeah, there are more than one ways of solving a problem. But in this class, in numerical class, we are interested in the approach in solving it. So if I ask you to use a particular approach, sometimes you have students, you ask them to solve using Gaussian method, then they go using the scale pivoting technique, or solve using range Qtard, and somebody goes to use Taylor series. I'll mark you wrong. Okay, so take note of that. The fact that you know so many techniques does not mean that you can use any when it's been stated clearly to use a particular method. Good. Any question at this junction? Any questions so far? Edna, any question? Okay. Yeah. Okay. So in the absence of any question, then um, I think that will bring us to the end of system of equations. Okay, for this that, which means that the next thing we'll be looking at will be with the numerical solutions. Okay, alternative solutions to differential equation, which I'll give you some time to go and do some reading. Just a minute, please. Okay. Yeah, but before that, let's try. No, we still have Gauss-Seidel. Okay, Gauss-Seidel to try. Okay, to look at. So let's look at the Gauss-Seidel technique too, which are more iterative steps. Okay, in solving the any system of equation. Yeah, there is supposed to be an assignment, but I'm not seeing it. That's why I keep going forward. There's supposed to be a work somewhere. Okay. Okay. So yeah, that is the second example on the Gauss-Jordan. Now, before we proceed, okay, we are supposed to. I told you last week that for this topic we've looked at, that's for the Gaussian elimination, we are supposed to write a program which can be used to solve any given dimension of linear equations. Okay, good. So from now, over the weekend, you want to sit on that and write a program which can be used to solve any system. I think that should be assignment 4 if you've seen it on Limas. Okay, so you're supposed to write a program, and I'm limiting you to C++, and yeah, I will limit you to C++. And for those of you who have MATLAB, know how to use MATLAB, you can make use of that, okay, to write a program for me. So C++ and MATLAB, please take notes, okay? So don't come back and tell me that, sir, I only had Java available, so I use Java. I'm limiting you to C++ or to MATLAB, okay? So you write the program to solve any given dimension for me. And I'm going to think about how you're going to present it, because ideally students are supposed to present it for me. So make sure you learn every step. In class, I may call on you to present it for me, okay? And then run it from your computer. So you will do the sharing on that day, okay? So take note of that. Yeah. So we have another example here, okay, which has been solved. It's been solved, but I want you to solve it yourself, okay? Though I have the steps there, let me give you some time to try your hands, okay? Like I always say, this numerical techniques is just not about presentation. It should be more of hands-on. So take this system. You're going to take this system and then use the Gauss-Jordan method to solve for it. And I want you to use a full expansion, which will be A, okay, BI, and then convert it into the form what? IB, IB, A inverse for me. Okay, so solve it at your end and give me the feedback whether you are getting the same results. Okay, do that for me before we jump to the next topic. So let me give you some time. I think I can give you about 7 minutes to do this for me. Yeah, has anybody finished?